Here is another example on finding the limit of a function. So in this example, we want to find the limit as t approaches 0 of the function 1 over t minus 1 over t squared plus t. Whenever we get the limit, our first option is the substitution method. If we apply the substitution method, then the limit will be equal to 1 over 0 minus 1 over 0 squared plus 0, and 1 over 0 is undefined, so let's copy it first. So 1 over 0 squared is also 1 over 0, so this is undefined minus undefined. You don't say equal to 0, so never say this is equal to 0. But if we result into an undefined minus undefined, then it calls for it means you need to simplify the function before you get the limit. In some books, you will see this undefined minus undefined as infinity minus infinity coming from 1 over 0 minus 1 over 0. Okay. So how do we get the limit of 1 over t minus 1 over t squared plus t? As we have said, we need to simplify the function. So instead of doing this, since substitution method is not working, we get the limit as t approaches 0 and then simplify the function. We have two fractions, so the way to do this is to add the two fractions or to subtract or to simplify the fractions. So we can use the LCD. So take note that t squared plus t is equivalent to t times t plus 1. So that means the t of the first fraction is already covered on the t squared plus t. Hence, the LCD is also t squared plus t. Okay, so when we divide t squared plus t divided by t, so take note these two are the same. So when you divide this by t, it means you can, or it will cancel the t, so the 1 will be multiplied by t plus 1. And then when you divide t squared plus t by itself, it will become 1, so minus 1 is minus 1. So limit as t approaches 0, t plus 1 minus 1, this is t over t squared plus t. And then again, we know that this is t over t times t plus 1, the equivalent expression of t squared plus t. And this will show, or you will see, that we can cancel t and t. Hence, the function is now transformed to 1 over t plus 1. Once you have obtained the simplified version or the simplest form of the function, you can already use the substitution method again. So we have 1 over, substitute t, 0 to t, so you have 0 plus 1. This is 1 over 1, or equal to 1. So that's it. That's the limit of 1 over t minus 1 over t squared plus t. To summarize the solution, whenever the substitution method fails, it means you have to simplify the function. Since you have two fractions, the tendency is you combine the two fractions and then simplify it. In most cases, you will be able to cancel some expressions, and that will lead to the simplest form of the function. That when you use the substitution method, you can already get the limit of the function. Okay, so I hope that is clear. So that's the solution to this problem.